This is section 5.3, the indefinite integral. In this video, we're going to go through number 73 in your book. This is an example of a word problem where it asks us to use the integral to solve it. So this problem tells us that a water balloon is dropped and falls 5 seconds before hitting the ground. Determine its velocity right before it hits the ground, assuming an acceleration due to gravity of negative 9.8 meters per second squared. Okay, before we start this problem, let's first talk about the relationship between our position, velocity, and acceleration functions. So if you remember, to get from the position function to our velocity function, we can just take the derivative. And same thing, our acceleration function is just the derivative of our velocity function. But if we wanted to go the other way, we can just reverse all this by taking the integral. So if I have my acceleration function and I want to get to the velocity function, I can just take the integral. And same thing, from velocity to position, I can take the integral of that function. Okay, so going back to this problem, it's telling us that it has an acceleration of negative 9.8 meters per second squared, but it's asking us for its velocity. So we're given some acceleration function, but we want to get to the velocity function. How are we going to do that? Taking the integral. So let's start with what they gave us first, our acceleration function. Our a of t is equal to negative 9.8 meters per second squared. All right, and to get to velocity, like we said, we just take the integral. So you have the indefinite integral of negative 9.8 dt. This just becomes negative 9.8 t plus c is equal to v of t. So we went from acceleration to our velocity function by taking the integral. But remember, since this is an indefinite integral, we have to add a plus c over here. And this plus c is the initial value of our function. And since we're talking about a velocity function, this represents our initial velocity, or our v naught. Okay, so let's see what else they tell us in the problem. Because remember, they're asking for its velocity right before it hits the ground, so we're looking for some value of v of t. But right now we have too many unknowns. So they also tell us that it's dropped and falls for 5 seconds before hitting the ground. So it's starting at some point up here, it's dropped, and after 5 seconds, it's about to hit the ground. That's the point we're interested in the velocity. Okay, so we know the t we're going to plug in is 5, but we still don't have a value for our c. But we can assume that since it's being dropped, its initial velocity is just 0, because it's just sitting there until all of a sudden it's let go. So we're going to say that our t that we're interested in is 5 right before it hits the ground, and our v naught, or our c, is equal to 0 meters per second, because that's before it's even released. So we can just plug these values in and solve for our v of t. So I have negative 9.8 times 5 seconds plus 0 equals v of t. Multiply all this together, and you get negative 49 meters per second equals v of t. And that's it for this problem. I hope you found this video really helpful. The concepts covered in this video are true no matter what calculus class you're in, but all the sections and problems I referenced were from this textbook right here. And remember that if you're a registered Baylor student, we offer free tutoring on the first floor of Sid Rich. You can either schedule a one-on-one appointment online or just drop in whenever you're available during our business hours for free tutoring. For more information, feel free to visit our website.